First things first, we will be talking about wave particle duality. Now, you have heard a bunch of times that light behaves both as a wave and as a particle. I am going to change that definition slightly to say that light behaves as a wave when traveling, and it behaves as a particle when interacting. Now, there is an inherent ambiguity in my statement. Why does light know when to transition from being a wave to a particle? And what does interaction mean for that scenario? Well, when does it know how to behave? And that's the inherent built-in complexity to this problem. He wrote a principle that he called the principle of complementarity. He said in his principle of complementarity that photons and electrons were neither waves nor particles, but something more complex than either of these two things. Okay, let that sink in. So he said in his principle of complementarity that both photons and electrons are neither waves nor particles, but something more complex than either. Which means there is not a simple model that can describe these things. So that implies there is not a simple model adequate to handle all situations. So they had to come up with a completely new field of physics called quantum electrodynamics, QED, which is a superposition of quantum mechanics and special relativity just to come up with an explanation of what these things are. So a new field called quantum electrodynamics which is quantum mechanics, superposition of quantum mechanics and special theory of relativity. And this field describes light and matter and their relationship and interactions. So how does this work? So I'm going to tell you a very simple way of thinking about this.